So good morning, all of you.
Good morning.
Good morning, sir.
Okay.
Good morning.
So I think yesterday I have changed the test case. So the test case has gone wrong here. I'll just show you this one. So this is all because that I have given something like double quotes in it. That anyway, when in the last class, even Saurith has discussed with me about that. But still, at that time, I thought, okay, it will be fine because it's a string. I am giving it like a string. But until now, we have been giving the strings without any double quotes, right? But this time, I really made a mistake of doing the giving the strings there. So that's the problem I am facing. So here, so I have removed the double quotes there. So anyway, they will come as strings to the input. Whatever you give, they will come as strings. So I thought they are not individual inputs. So let me keep as one string and give it. But it is possible because in the previous test case, I have clearly given like push, pop, and everything, right? They are coming as strings. Why don't this come as string? I did not think about that. So I have directly given like strings with double quotes, and every time it is taking the double quotes in your stack. So that is the reason why it is giving you something like 2. So those who have done using the stack data structure, they are getting all the test cases wrong. And if they do -2, they are getting all test cases correct, most probably. Some people did not use stack and they have used something else, different programming, which I don't encourage generally because I am giving this as a stack program. So if they do like that, they are getting something like first output is correct and the second outputs are wrong. Because people are simply trying to copy. I don't know whether how many of you have learned it. I don't know, but still people are trying to copy. And this is the reason why, most of the people are having same type of mistakes because they are applying the same type of pattern for the program. So finally, I have corrected it yesterday, and I think most of your test cases have run better. Okay, and I am sorry for this. Because of this, you have wasted some time by having some tension or so. So that is the reason why I have said yesterday, and I have corrected it. So I was testing yesterday with my program and others program and 2-3 programs. Then I realized that that is the mistake with the double quotes. And generally, this is the way you have to do your testing also. I have checked line by line. I have printed every value and the values are coming correctly, but the final answer is wrong. So then I realized that this is all because that the double quotes are also included. So that is already told that day by Saurith, but at that time we did not take it much seriously in the last class because at the end of the time he told that. So we are about to close the class and I did not realize the mistake. So later yesterday I realized the mistake of test cases should be the mistake there and I have corrected it. So right, thank you for your cooperation. And then we will go today for DQ. DQ is not your DQing or NQing in your queue. This is called double-ended queue, DQUE, that's all. DQUE, it's not QUE, right? So double-ended queue is also working like queue itself, but there will be some small difference in that. The difference is you can insert or delete a particular element from front or rear. In the queue, what you have done, you have basically added an element at the rear and you have deleted the element from the front, right? Because that is a queue. So you have added an element at the rear, that means backside. And because this is a first in, first out or first come, first serve basis, the element that comes first should be eliminated first if you want to DQ something. So DQ means I'm talking about NQing and DQing mode, not the double-ended queue. So when you want to delete any element, you go for deleting in the front. When you want to add any element, you are going for adding at the rear. That means the back side. Now, DQ has the possibility of adding and deleting on both sides. So that is why it is called double-ended queue. It works like your earthworm. So both sides you will have head, right? Any direction it can walk. The same way, any direction you can delete, any direction you can add. This is what double-ended queue. Now let us check out how you enqueue something in the beginning and also end. Look into the blue box. As usual, the blue arrow is always friend. The red arrow is always rear. Okay, this is the notation. Let me change the color of this, which is a pointer going through each line. Okay. Change another color. This is not the way. Okay, right. So now we are now going to the first instruction of enqueue-beg. Beg in the sense it is the beginning. So I want to enqueue something in the beginning. Whether it is rare or whether it is beginning, you should first check that whether both front and rear are -1. If both front and rear are -1, the first thing that you have to do is increment them to the 0th position. So front and rear should be both ++. And the difference here is in queues, when you want to insert an element into the queue, you always insert it at the position of rear. You say queue of rear is equal to the element, right? But here there lies a small difference. In enqueue beginning, you will put the element at the position of front. Now the front is pointing to 0. So we have to keep 5 at the position of front. Let me keep 5. Okay, kept it. Then we go to the next instruction, 6. Now it says that enqueue end. It says that enqueue end. That means this time you have to place your element at the end. Naturally, again, you will check whether front and rear are equal to -1. Because they are not equal to -1, and I said I want to add an element at the end of the queue, that means the double-ended queue, I have to increment my rear to its next position. So it is now at 1. So increment by rear at its next position. And as I said to you, the beginning means you have to keep the element, the new element, at the position of the front. But now you will keep the new element at the position of the rear. So keep the element at 6, the element at rear itself. Now come to the next instruction. Enqueue end again. What is that we need to do now? Can anybody tell me?
Rear is equal to rear plus 1.
Yes, correct. Because they are not -1, rear is equal to rear plus 1. So rear will be now pointing at 2. Okay. And this is where you place your 7. Now coming to the next instruction, 10. Haha. So what should we do now? I said that the 10 should be placed at the position of the front. The front is at 0, which is holding 5 as an element. But I don't want to replace 5 with 10. It should be something like 5 should also be there, 6 should also be there, 7 should also be there. But where can I insert 10 now? Any idea from your side?
Front is equal to rear plus 1.
Okay. Front is equal to rear plus 1. No, you cannot bypass front to rear, right?
Then maybe rear. Rear itself.
Amma, I did not understand. Can you repeat it?
Front is equal to rear, replacing 7 with 10.
But we cannot replace anything. I want 10 to be front of 5, 6, 7. So the final queue should look like this 10, 5, 6, 7. What
We
should
need
I
to
do?
push the values to the next.
Yes, that's correct. Pushing the values to one side over to the next. So what I do for pushing, when I'm going through the list, I will write a small while loop, this one, which is the loop. So I will take this arrow as I. Okay, this arrow which I am highlighting as I, the yellow color one. So that is the reason I have same colors for them. So this is the code for moving this one. So what I will start, I will keep I with rare. So I is pointing to the same value where rare is pointing to. I will go, see this line which I have highlighted, while I is greater than or equal to friend. So I'm going up to friend, not up to, including friend. I'm going to friend. Okay, not up to friend. Up to friend means we have to stop before friend. So we are stopping at friend. That's why I have given I a greater than or equal to friend. Then what I have done, if you consider this one as q, I have given like this. Q of I plus 1 is equal to q of I. Now at our condition, what is I now? What is the value of I?
2, sir.
2. So q of 2 should be now copied to q of 3. The reason is q of I plus 1 is nothing but 2 plus 1. So q of 3 is equal to q of 2. So what you are assigning q of 2's value to q of 3. Now we will copy this value and put it at this position. So I'm copying it. 7 has been copied. That's all. Now what is the next thing I am doing? I is equal to I minus 1. So I will move this to this one. Now it is pointing. The I is at one position. Okay. Again, it is checking while I is greater than or equal to friend. Yes, I is greater than or equal to friend. Now what should you do? You should enter into it and look into this statement. Q of I plus 1 is equal to Q of I. So copy this one into its next position. Copy. So 7 will be replaced with 6. Right? This is what happening. Again, I is equal to I minus 1. So I'm now coming to front. So both front and rear at the same position, right? Now, again, I will enter because it is equal to, right? Q of I plus 1 is equal to Q of I. So just a second. Okay. So I will copy this and paste it into this. Fine. That's all. And even if you make q of I is equal to I minus 1, what will happen? It comes to minus 1, which will not satisfy the while loop. That's the end. So after coming down, you have to do two things. You have to insert 10 at front position. So because 5, 6, 7 are safe now, you can just say that q of front is equal to the element. That means 10. Fine, right? And rear is equal to rear plus 1. So now everything is perfect, right? Because rear is pointing to the last element and front is there itself. Because nothing is dequeued until now. We have been just enqueuing it. That's all. We are not dequeuing it. So front will be there at the first position only. And rear is increasing because one more element has been added. See the difference between that Q and DQ here. In Q, you are always adding an element at the end, but in DQ, you are also adding an element in the front. So just now you have seen how you can add an element at the front. Okay. Now come to the next line. So by this time, we are just removing I there and keeping somewhere else. Okay. So let's go to the next thing. So in this condition, you are saying you have to add something at the end. Very easy, right? You will just move the rear is equal to rear plus 1, and wherever the rear is pointing it to, you just keep the value there. 16, right? Now coming to the next instruction, NQ beginning, it is 100. So what should I do now? Where should I add 100 now?
Beginning, sir.
That means you have to add 100 before 10. Let's take our hero I. Again, make it. So whenever you say a function, so now you understand what should be important code in your function, NQ beginning and NQ end. So for NQing, for in the queues, we have only one function, NQ, some element, but we have two functions here. One is NQ beginning, the other one is NQ end. So end is very easy. Just you check for -1s. If it is not -1, then you just add rare is equal to rare plus 1 and insert the element in the rare's position. But to insert an element in the friend's position, you have to go through all the elements to keep it to the next, next element. Copy that and paste it to the next one. That's definite. And of course, you are going for, I think it should be n square complexity when we are doing that thing. If something is more, you can reduce the complexity, that's also fine. Yesterday, I have been discussing with Mohan and he said that he has written a code. I have written in n square, the brackets problem. And he said that I have done it in n, big O of n. So I said that I will discuss with you later. So if you have, because I always say I am an 85 brain person. Okay, I'm born at in the year of 85, but you are born after 2000. So your brain should be more active because your brain is young. You can try out more code. It's just a hint I will give you, right? You can go out with your own code, but don't cross the limits of our, what we say, principles. If I'm giving that something should be done in stack, you have to do in stack. So this time it will be okay. I encourage that. But next time you should be going for stack, because when you go for companies, they will clearly give you the instruction that you have to do this program using stack. You have to do this program using queue. Then that will be fine because they understand that the program solution importance is in stack and or in queue or something. That's why they give you the instruction to do that. Okay, coming back to this. So let us start with this and copy everything. So we will go through each one because I is equal to rare. We set the I to the rare position. And then again, we check the condition and then we copy this one and then I minus minus. If we do such things, then this, excuse me. Yeah, then this will be copied into this one, 16. And your thing will be pointed out to this, then copy this 7 into this one, and again your I minus 1, and then copy this one to I plus 1, sorry, and then copy this one -1, I minus 1, then copy this one to this one, and again I minus 1, and copy 100 to the next, sorry, 10 to the next, copy this one, right? And the final thing that is remaining is that again, after copying, your I minus will be there, right? So I will be going to -1. So coming out of the loop, you have to do two things. One is to add the element at the front position. That's all. And the other thing is to just move the rare. Rare is equal to rare plus 1. These are the two things that you have to do after you come out of the while loop. So this is all about double-ended queue insertion. Now, if you want to dequeue it, there are two functions for dequeuing also. Dequeue at the beginning, dequeue at the end. So when you want to dequeue at the beginning, so I don't want this now, you just increment your for here. So how many elements are there in your dequeue now? Double-ended queue?
5, sir. 5, sir.
5. because it starts at 1 and ends at 5. 1, 2, 3, 4, 5 elements, because it starts from front and ends at rear. Now, if you again DQ at the beginning, the front will be incremented. If you want to DQ at the rear, then you say DQ end. So you say that rear is equal to rear minus 1. So whenever you want to insert an element, again, NQ at the end, you can simply increment rear and replace 16 with the new value. That's all. But now we are DQing at the end, right? So the rear will be minus 1. Again, DQ at the end, rear will be minus 1. Right? Again, DQ at the end. So rear will now point to the same value front is pointing to. Now here comes all your solutions. So find out different problems that you encounter in DQ. So DQing at the front and DQing at the rear is happy. You can just simply, if you want to DQ at the beginning, increment your front. If you want to DQ at the rear, decrement your rear. That's all. This is how you actually do it. But when this both are pointing to the same location, like how I'm showing you now, both are pointing to the same location. You can see here, so that, okay, now both rear and front are pointing to the same location too. Now in this case, I want to DQ at the beginning. What should I do now? Can you just say front is equal to front plus 1? Hello? What is the principle that we have discussed? Can front bypass
Front can't bypass rear, sir.
rear? So what should we do if we want to make it in the beginning?
Sir, increase or decrease both.
So front means if you want to delete at front, front should always be incremented. But because rear is also pointing to the same thing, either we can think that we can increment both and come to the next position. So I can make this here, and along with that rear also coming to this one. And from here we can start NQing or something. If you want to DQ at the end, rear should be minus 1. So what can we do now? What can we do now?
Decrement both.
That's all. That's what we can do. But you can also produce some errors if possible. You can say that we cannot delete it because both are pointing to the same thing until NQ some element. So you can also produce some error such that. So find out what are the difficulties that you are facing while you are coding. What are the different test cases that you can do? So that means test case scenario in the sense, sometimes you can NQ out of bound. That means, for example, your front is at 0, and by this time, this is one scenario. Your rear is at 7 and entirely filled, and you want to still add it at the end, no space. So what you will produce? It should be an error, right? Because it is overfilled. Now, if, for example, you are making your front fill, but front is here and everything is filled because you cannot move the rear. And of course, it's very easy to identify that when you want to NQ something at the rear, you can just check the rear value and say that I cannot increment rear because rear is already facing at length minus 1 position, length of the queue minus 1 position. But coming to the front, if you start doing it like this, it is not possible, right? You cannot start with rear and do it. So for adding in the front also, you have to check whether the rear is pointing to the last element or not. Because if you want to move also, this element which is there in 7 has to be moved to 8, but 8 is not there in your index. This is out of bound index. To construct your house, because there is no space, can you go out of Punjab and go to Pakistan, Punjab and construct your house? No, it is not there. You will get arrested immediately. The same thing happens here. You cannot go beyond what is your border or the limit. So for this, you have to see that both when you want to enqueue in the beginning and end, first you need to check whether they are -1s or not. And the other thing that you need to check is that whether the space is there for them to accommodate a new element or not. How do you check the space? You need to check it using RARE itself. Because RARE is only moving whenever you are adding some element. For example, even the front is at this position. If the front is here, so total number of things are like this. So I'll just copy and paste it here and write some other value. So 161 or something. Okay, and copy this and paste it. So I have given some values. Okay. Okay, 11 or 21 something. Okay, right. Now this is the case. Can you add any element now? Can anybody tell me? In this case?
No, sir.
You cannot add because you discarded 100. This is not a circular queue. I'm talking about double-ended queue, which is almost like queue, but you can add both sides and delete both sides. That's a small difference that you have. You are just deleting 100. So you start at 10 and end at 121. There is no space for you to even put the element because RARE is always important for you to insert either end or beginning. So you should check this condition also. If everything is proper, then you can go for keeping I at RARE and -1, -1, -1, and so on. That you need to remember. Okay. So this is the these are the conditions for enqueuing, and also the conditions for dequeuing just we have discussed. See different scenarios like this. Experiment with different scenarios and find out what are the difficulties that you have and what are the conditions that you have. That we will discuss in the next class. So now what's the time? I will now discuss with you about a micro project. In the afternoon, in the next class, we will either discuss about priority queue or we will also discuss about the dequeue implementation. What are the difficulties that we have? We will do the coding along with you so that you and me will understand what are the difficulties that we face. Okay, right. So I will now explain you a micro project. I am not even calling it as mini project. The micro project is as such. So when I'm running this one, you tell me what is happening inside. This is an executable file. I have written an operating system.py program in Python, whose task is to put all the process in a queue. 1 second. There is a lot of disturbance because of this storms, I think. So I have written an operating system.py program which runs all the process. What do you mean by process? Process is something like a program that you are writing. So remember, operating system is also a program, entire program of different modules. There is some small module that is written in C and C++ in the kernel mode in Linux, if possible. What this program will do is, whenever you want to execute a particular software, whether it might be a browser, opening a browser, or whether it might be opening some game, executing it, or you are running a program itself. All these are called process, or whether you are trying to print some paper, you are trying to give a command to the printer to print something, is also a program. So what this operating system program will do, it will keep all these requests in a queue. And one by one, each request will be served. Each request will be served. First, for example, printing comes. And then in the queue, the next request is opening a browser. And the next request is playing a game. So each one will be executed one after the other immediately. So I'm not talking about parallel processing. I'm talking about a single core processor which only executes one by one. Okay, like your mobile, naturally, see, sometimes you can open YouTube and if you close it, you can next open browser. The programs might not run there, right, parallelly. So I have written a small program and converted it into an executable program. So this is what I am now clicking. See what will happen. So I am printing. Now the printer is printing now. After this, it is now opening the browser. And after this, it is now starting the game, right? So what happens here is after completing, see, it is saying that I have completed the task. What happens in my program is that I have written a small program in Python, which will actually take the strings as the names of the program itself. So for example, the commands to run a program, I will write a command, right? So generally what I do to run a particular one. So for example, Python 3 printing.py. So it is saying, hi, I am printing. Now you see, I am just trying to execute an individual program. But what I am doing, if I write operating system.py, I am trying to execute itself. For example, see what I am doing, Python 3 operating system.py. See, it is doing the same thing what I have done. So it is calling the program print.py. It is opening the browser and it is starting the game next. That's what happening, you see. So now you can now understand what is happening inside. So there is a program which takes all the commands and put it in a queue. What to do next? One by one, it serves it. So it executes a Python program first. After that, it goes to the next element in the queue. The next element is nothing but opening a browser. It will now go to the next element in a queue. It is nothing but starting a game. For starting a game, what I have done is simply that I am not starting a game really, but I am going for just a second. I'm just writing a HTML page like this. So I have written HTML open and close and H1 game starting and H1. H1 in the sense it's a big heading. You can just use this particular code for your executions or whatever you want to write, you can do it, asking the page to be opened. So your task is to now find out the commands. How do you open a browser? How do you run a browser? How do you open a HTML page using a browser? These are all the things that you have to do, you have to think about. This is one task that you have. And the other task is how you keep these commands in a queue. When you ask the operating system to execute, how it is going through each command and executing that particular process. How it is running a Python program. First of all, how do you keep all these things in the queue is the first thing that you have to do. How you are running them through the program itself. See, in the terminal you are running, right? Using terminal you are running here. But the same thing I am running in a program itself. So I will give you a hint, something like you can import a library called OS and os.system will give you something. Whatever that you write in the system will be run in the terminal and everything works fine. So I have given you a hint now. The next thing that you have to do is you have to find out what are the commands to be implemented and how you have to keep them in a queue and one by one how they are served. This is the real-time example of your queue. So the program that you are writing is actually how it works in your operating system. In your daily life, sometimes you open a browser, you open VS Code, you run a program, you do a lot of things, right, one by one. These are all kept as process requests in a queue. Each process is sent by the operating system into the CPU for execution. This is how it is happening. So when I have started explaining about queues, I have told you how this real-time working will be gone through using a theoretical aspect, writing something on board. Now you are doing your own program in Python. So I hope you understand this one.
Sir.
Yeah, tell me.
So the program which we will be writing, will it be running on Python virtual machine or directly on the
Python virtual
CPU?
machine, Python virtual, everything is virtual here. Okay, you are creating a simulator as if you are creating a small module for operating system. Did you understand?
Yes, sir.
Yeah. So now what happens here? The next thing is you should not submit me the operating system.py. You should submit me an install the executable file. How do you execute it? You have something called PyInstaller. Using PyInstaller, you can convert your Python program into an executable file. So there is no need for me to run all these things. So when you create an executable file, these are the three things that will be created. These are the three things that will be created. So what I want as your assignment, after creating this one, after creating your program and converting into executable file, you have these three files, and along with that, all the necessary files like this, which are really necessary for execution, including the .py file, okay, should be kept in the dist operating system mode. So you have to copy here. So how I copied here, you see, you have to copy these game.html or something like operating system.py program and printing.py program in this particular one. Make it as a zip. So or otherwise you keep it like that. So you say that zip build dist operating system spec game.html, something like printing.py and operating system.py as zip, and upload the zip to the assignment. I will tell that zip should be uploaded to the Moodle. I hope you understand. You keep all these folders, build dist operating system.spec, game.html, operating system.py and printing.py. So it is not compulsory that game.html and printing.py should be there, but I'm talking about you can write your own program or you can do the same things. Not a big problem. So just upload the zip of all these things. Don't include any other into any other folder. You keep the folders like that and just make these things into zip. So you can say you can compress it, right? If you say compress in Windows or thing, it will form as a zip like this. So this is what the archive contains. So this contains all these things. Build dist operating system.spec, because the name of the program it will come. Not every time operating system. So operating system.py, game and game.html and print.py will be containing in this archive. So you need to now upload this archive.zip to my assignment, which I will create. So maybe I will give it up to next week, Wednesday. You can try out all this week. It's a very micro project. It's very easy. Just to make you understand how queue works in real time. You will have a confidence that you are writing your own operating system module program. Remember, Windows works on DOS, disk operating system. Linux works on kernel, and Mac works on Macintosh. Why I'm saying DOS, kernel, and Macintosh? They are nothing but programs written in C++ in a module wise. For example, you install a driver for your new, what we say, a USB or something, right? What these drivers will do, they interact with the port programs. See, for every port, like the USB port is there, right? There will be a program in the operating system that catches whatever the input that comes from the port. So for this, you are bridging a gap. So when I insert a USB, please try to read the USB. For doing that, you are installing a driver into your operating system. So these are external programs included into the kernel. So that program, whenever you insert a USB, the driver starts working and tell the operating system that please read this one. So remember, everything is a program in operating system. Running the process in the CPU is also a program. That's what you are writing now. Executing something is also a program. Everything depends on the operating system modules. Reading something from your CD drive or pen drive is also a program. There are different modules for each case. And in this case, the module that you are writing is to send the programs into CPU and get executed. You are doing everything in virtual manner. You're not directly writing anything in your operating system and working on the CPU. You are doing a small virtual program, like your game simulators, like bus simulator, truck simulator, train simulator. You are using an operating system simulator. A very small program in which queue data structure is very important. You queue all the programs one by one and execute them one by one. So now your task is to write the program and also find out what are the things that are really necessary for executing this program. Right? Your task is to only create operating system.py. And when you try to use PyInstaller and do it, these folders will automatically get created. Just a second, I have chat. Sir, can we use predefined modules, sir? Like, for example, from collections, import DQ. No. You have to write your own queue. You have to write your own queue and you have to keep your process in that queue and run each process one by one. Giri, I am telling you, or anybody who got the same doubt, one by one. And you have to know how to execute each process now. For Python program, what is the execution command? So you can put along with the execution command also. So how do you open the browser? You write the entire command, including the browser name, and put it as an element in a queue, as a string, and that should be executed. How do you execute is something like this. For example, when you are enqueuing, you are putting all the process in a line in a queue. When you are dequeuing, it seems that it should be executed. That means whenever your front is increasing, each process will be executed and the front will be increased. Then the process will be executed and the front will be increased. That's how you have to dequeue now. It's not like putting the elements and deleting the elements like what we have done until now. It's a real-time execution of queue. Each element in a queue is a real-time command process. Whenever you are dequeuing it, the process has to be executed and you have to increase the front. And that's how you have to do the program. Any doubts in this? Giri, I think I clarified your doubt.
Yes, sir. Sir, one small doubt.
Yeah, tell me.
Sir, while enqueuing, we need to take them as a strings, sir.
Yes, definitely.
The executable file also.
Yes, yes.
Okay, sir.
So there are no executable files here. Everything is a program, right? So you should know the command of how to open a, you need to test it in the terminal first, how to open a browser using terminal or your DOS mode, command prompt mode or something. There are commands. You can do that. So the system function in Linux and Mac will work as terminal, but in Windows it works as command prompt. So you need to find out how you can open a browser using command prompt or terminal, how to run a program using command prompt or terminal. Like that, you have to run it. And for the HTML page, you need to understand how I can open a HTML page in a particular browser. So you need to go searching in the internet and do this program. I hope you understand. Fine. Any other doubt?
So the task like opening a HTML page, opening a browser will be given by you, or will it be predefined, sir?
No, you have to create your own command.
Okay,
I
sir.
will not give it. So I have given
Sir,
the
for this,
task.
there is no auto grading, no, sir. It's manual.
Yeah, I will write a program for myself. There will be no auto grade in the Moodle. I will, after you upload the zip, I will download the other thing I have to say that this should be worked in groups. I think we already discussed about forming groups. Have you formed it already?
No, sir, not really.
Yeah, you
What's
have to form it now. So maybe by tomorrow or day after tomorrow, I should get your groups because I have to add you as groups and create a group assignment. So keep 4 members in a team. Keep some 4 members in a team and they have to work together. And the other thing is that if somebody is not working, the team leader is responsible and he has to inform it to me, because if he is not working and he is also getting the same marks as you, then not all your hard work is waste of time. He has to discuss with you, he has to learn what you are doing and help you in doing that. Give some tasks to him. Find out the command of how to open a browser. Like that, you have to give a task to him and he has to help you. So the team leader, you yourself decide who is the team leader of your team, and he is responsible for giving all the works to the others, including himself. So from now onwards, you have to inculcate the habit of having a team work. Okay, collaboratively. That really works fine. And it's all your plan how you divide the work among yourself. This is one thing.
Sir, this micro project is with regarding to the groups or individual?
Group, that's what I'm saying. This is
Okay,
for group. Once you form the group and give me all the groups, each group, for example, seer of this class has to coordinate this one. So people give the group names and seer will divide them into batches, batch 1, batch 2, batch 3, batch 4, like that. And just pass on the entire list to me. I will create it in the Moodle, it as a group. Okay. So, and then I will create a group assignment. So one zip file for a group is enough. Once I award you the marks for that particular one, all will get the same marks. I hope you are understanding that. Did you understand what I'm saying?
Yes, sir.
Okay, that's good. So any other doubts? You first form the groups. After you form the group, I will upload the assignment for you. In the meanwhile, you can go on with that. And after you write the program, you just upload as a zip file. And I will download all the zip files to my computer, and I will try to execute them virtually using a Python program, and I will look into that. So based on execution and how it works, I will give you the marks. Okay. Right then, we will close the session now. Bye-bye.